Okay, so in this video we're going to look at atomic structure and the periodic table, which you would have studied in detail in year 9. I'm just going to go through the most important parts of it. First bit, atoms are made of protons, neutrons and electrons. You should all know that by now, okay? But make sure you know the charges, okay? So protons are positive, electrons are negative, neutrons are neutral. Make sure you know the mass, so how heavy they are. Protons and neutrons have a mass of 1. Electrons are basically 1,835 times lighter than protons or neutrons. So you can memorize either 1 divided by 1,835, or you can remember the word negligible. You can't just write 0. It has to be 1 over 1,835 or negligible for the mass of an electron, okay? And you need to know that protons and neutrons are found in the nucleus and electrons are found in shells. So know the charge, know the mass, know where they are found, okay? That's just something that you have to learn off. And I do lots of worked examples and typical questions that they might ask you on that, okay? But know this table off by heart. The second thing is, you know that atoms contain protons, neutrons and electrons, but you need to be able to tell me how many protons, neutrons and electrons each element contains, okay? And I just want to show you, because this is the periodic table that you're going to have in your exam. It's the official GCSE one, okay? And you've got a key that tells you how to read your periodic table, okay? So if we look at lithium and if we look at a key, okay? Relative atomic mass is 7, okay? So the top part, the 7, is your relative atomic mass or your mass number, okay? If you remember your table, there are 2 particles that have mass. Protons and neutrons both have mass. So the mass number tells you how many protons and neutrons you have if you added the protons and neutrons together, okay? It doesn't include electrons because electrons are really, really light. But relative atomic mass, which is the larger number here, tells you the amount of protons and neutrons that you've got. Next up is the atomic symbol, okay? So for lithium, that's going to be Li. Next up is the name. So for lithium, it's lithium, okay? And then the number at the bottom is the atomic or the proton number. So it tells you on your periodic table that this number here at the bottom is the number of protons. So if the number for lithium is 3, then it's got 3 protons. For magnesium, that bottom number is 12. It's got 12 protons. For scandium, it's 21. It's got 21 protons. So that number at the bottom tells you the number of protons. Okay, it's on your periodic table for you, so there's really no excuse for getting it wrong. The bottom number is the atomic number, which tells you the number of protons. So if I go back and look at my example, I've got phosphorus with a mass number of 31 and an atomic number of 15, and I want to work out how many protons, electrons, and neutrons phosphorus has got, okay? Again, on my periodic table, it tells me that the protons is the number at the bottom, and for phosphorus I see that's 15, and that tells me that I've got 15 protons for phosphorus. The number of electrons is always the same as the number of protons, so if you've got 15 protons, you've also got 15 electrons. To calculate the number of neutrons, you take the big number, which is 31, and you minus the small number, and you get the number of neutrons. So protons, small number, electrons is also the smaller number, neutrons, big minus small, is 16. That's protons, electrons, and neutrons. If I did the same for fluorine, the numbers are 19 and 9. Protons, electrons, neutrons. Protons is a smaller number, it's 9. Electrons, always the same as protons, so it's also going to be 9. Neutrons, 19 minus 9 equals 10. Make sure you can work out the number of protons, electrons, and neutrons, and make sure you know what those numbers tell you. If you are asked, what does the atomic number tell you? It tells you the number of protons, okay? Number of protons. In terms of atomic structure, we're just going to look at how atoms are arranged on the periodic table and how that fits in with their atomic structure, okay? So if I'm looking at my periodic table, again, hopefully you remember this, but these vertical columns are called groups. So going down, I've got group 1, group 2, group 3. So those vertical columns are called groups. But my horizontal rows going across, they are called periods. So going across, I've got periods. Going down, I've got groups. One of the most common mistakes is when you are asked where period 1 is, people start here with lithium and they say lithium is in period 1, okay? Lithium is not in period 1. Period 1 starts here with hydrogen and helium. This is period 1. Period 2 starts here with lithium, so it includes lithium, beryllium, the whole way across. Period 3 starts here with sodium. So if you were asked to name an element from period 2, you could take any of these elements in period 2. Okay? If you were asked of an element of period 1, you say helium or hydrogen. An element from period 3, you would take 1 from here. Okay? Just remember, period 1 is hydrogen, which means lithium is the start of period 2. So often, students start counting period 1 at lithium, and that is incorrect. Okay? Horizontal rows are called periods, and the vertical columns are called groups. Other thing you need to know about the periodic table, okay, is how it's arranged in terms of electron configuration. Okay, so we know that electrons are found in shells around the nucleus. And if you were to draw out an electron shell diagram, okay, so just say phosphorus, I have got 15 electrons to draw. You need to know that of those 15 electrons, I can put 2 in the first shell. I can put 8 in the second shell, which gives me 2 and 8 is 10. And I've got 5 electrons left. 5 electrons will go in the third shell. So if you just asked to write the electron configuration, that's all you would need to do. If you were asked to draw it, you'd go 2 in the first shell, then it's full. I'll move on to the second shell, and I put 8 electrons in there. The second shell is now full, and I've still got 5 electrons left, which will go into the third shell. And I see that phosphorus has got 5 electrons in its outer shell. If I do fluorine, okay, I've got 9 electrons. I can put 2 in the first shell. That leaves me with 7, and they will all fit into the second shell. So fluorine would be 2 in the first shell, and it would have 7 in the second shell. Okay, and I would just write that as 2, 7. Now, if I look at my periodic table, what I will see is that phosphorus is in group 5. And when I draw out phosphorus, I see it has 5 electrons in its outer shell. And that's true for every element that's in group 5. If it's in group 5 and you draw it out, you will see it has 5 electrons in the outer shell. Fluorine is here in group 7. When I drew out fluorine, I saw it had 7 electrons in its outer shell. If I drew chlorine, which is also in group 7, I would again see 7 electrons in the outer shell. So the group number matches the number of electrons in the outer shell. So magnesium's in group 2, 2 electrons in the outer shell. Lithium's in group 1, 1 electron in the outer shell. Carbon's in group 4, 4 electrons in the outer shell. The other thing I can see is that phosphorus has got 3 electron shells, whereas fluorine only has 2. If I go back to my periodic table, I will see that phosphorus is in 1, 2, 3. Phosphorus is in period 3, whereas fluorine is in period 2. So the period number tells you how many electron shells they have. Fluorine's in period 2, it only needed 2 shells. But phosphorus was in period 3, and it needed 3 shells. If you were to draw bromine, it's in period 4, you would need to draw 4 shells for bromine. So the electron configuration, which is how the electrons are arranged, relates back to the periodic table. Okay? You'll also see on my own periodic table, I've got charges above the groups. Okay? That's because if elements have the same number of electrons in their outer shells, they're also going to react in the same way. So example, all of your group 1 metals have 1 electron in their outer shell. They will all lose 1 electron, and they will all form +1 ions. So lithium will form +1, sodium will form +1, potassium will form +1. They'll all lose 1 electron, they'll all form +1 ions. Your group 2 will all have 2 electrons. They will lose those 2 electrons, form +2 ions, and so on and so on. Okay? Your group 5, don't have that one filled in, okay? They will gain 3 electrons, and they will form ions with a -3 charge. So the periodic table, the way the elements are arranged, relates to how their electrons are arranged, their electron configuration, but it also relates to how they react. All group 1 metals lose 1 electron, form +1 ions. Okay. The other thing to know about the periodic table is that it's split with metals on the left, non-metals on the right, and it's split right here if you draw your little stairs. Most of the periodic table are metals, all of them to the left. On the right, you've got the non-metals. Hydrogen, is important to note, is a non-metal. So I have it here floating out in the middle. So it's on the same side as the metals, but hydrogen is not a metal. It is a gas, and it belongs with the non-metals. Okay, so please remember that hydrogen is a non-metal. Okay, that's atomic structure in an absolute nutshell. We're just going to have a look at some questions that I want you to try for me. Just press pause and just test yourself. Do question 12, 13, and 14 and 15. Just have a go at those few questions. Press pause, do those few questions, and then press play when you're ready to see the answer. Okay, we'll go through the answers. What does the atomic number of an atom tell you? It tells you the number of protons. You won't get a mark for writing number of electrons. You have to say atomic number is number of protons. And it's there for you on your periodic table. Atomic number is number of protons. What does the mass number of an atom tell you? There are 2 particles that have mass, protons and neutrons. The mass number is the number of protons and the number of neutrons. What is the atomic number of oxygen? Small number next to oxygen is 8. That's the atomic number. The mass number of neon is the big number next to neon, which is 20. How many electrons does nitrogen have? Atomic number is 7, so it's got 7 protons. It's always got the same number of electrons, so 7 electrons. Protons does fluorine have? It's going to have 9. How many neutrons does boron have? 11. Neutrons, I'm going to do 11 minus 5, so 6 neutrons. Which atom has the most mass? That's going to be neon, because it's got the biggest mass number. What is always different for atoms of different elements? The number of protons is always different. That's how you identify an element, based on the number of protons it has. And something I actually forgot to mention is the 2-mark question below, what is an isotope, which I actually do want to run back and do with you quickly. Okay, so here I've drawn out isotopes. Okay, so what I have is I've got lithium. And the reason I know that each one of these are lithium is because each one of these has 3 protons. So the protons are the red circle, and each diagram has 3 protons. So each diagram represents lithium. Okay, you'll notice that they've all got 3 protons and they've all got 3 electrons, okay, which is lithium, but there's a different number of neutrons. There's a different number of yellow circles. I've got 3 neutrons in the first, 4 in the second, and 5 in the third. And when you've got atoms that have the same number of protons, but different numbers of neutrons, we call them isotopes. You need to know what an isotope is, okay? You need to know that definition. Isotopes are atoms with the same number of protons, but a different number of neutrons. And what this will mean, because they've got a different number of neutrons, they will have different mass. So the mass of this neutron is the number of protons plus the number of neutrons. You've got 3 yellow circles, 3 red circles, you've got a mass of 6. Over here, you've got 3 red and 4 yellow, giving you a mass of 7. Over here, you've got 3 red and 5 yellow, giving you a mass of 8. So as you've got an extra neutron, you're increasing the mass by 1. So the mass is different for each isotope. In terms of their reactions, you'll notice that they all have 3 electrons. And when you're talking about elements reacting, you only care about the electrons. So even though they all have different masses, they will react in exactly the same way because they've got the same number of electrons. And it's the electrons that determines how an element reacts. Okay, so different masses, but they have the same number of electrons, which means they will have the same reactivity. Know this definition. Isotopes are atoms with the same number of protons, different numbers of neutrons. last thing I wanted to do was just in terms of the periodic table, okay, made by Mendeleev. We've already talked about electron configuration, okay. But if we have a look at some practice questions, just have a go at these for me. You'll need a periodic table. Blah, 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 blah. 17, 18, 17, 18, 19, 20, 21. 17, 18, 19, 20, 21. Have a go at those 5 questions and then press play when you're ready to see the answers. Okay, so in 17, you're asked for an element in group 2, period 2. Okay, so I go to my periodic table and I move into group 2. And I know that period 1 starts with hydrogen, so period 2 is here. So my answer is going to be beryllium for group 2, period 2. For group 5, period 2, I'm going to stay in the same second row and I'm going to move across to group 5 and I'm going to see nitrogen. So group 5, period 1, 2 is nitrogen. For group 7, period 3, okay, so I'm going to go to group 7, period 1, period 2, period 3. Group 7, period 3 is going to be chlorine. Write the electron configuration for potassium. So I need to know what number of electrons potassium has. It's got 19 electrons. If it's got 19 electrons and I want to write the electron configuration, it's going to be 2 in the first shell, 8 in the second shell, 8 in the third shell, 1 in the fourth. Okay, that gives me 2 and 8 is 10, 18, 19. So all of the electrons are assigned. And it fits the periodic table. Okay, potassium's in group 1, so it should have 1 electron in its outer shell, and it does. It's in period 1, 2, 3, 4, so it should have 4 shells, and it has 1, 2, 3, 4 shells. So I know I'm right. The last one I asked you for was the electron configuration for sulfur. Sulfur's got 16 electrons, okay? So it's going to have 2, and 8 is 10, and 6 is 16. Again, 6 electrons in the outer shell. Sulfur's in group 6, so that fits. Period 1, 2, 3, and sulfur's got 1, 2, 3 shells. Okay, so make sure you're comfortable with writing how many protons, electrons, and neutrons are in an atom. Make sure you're comfortable with writing the electron configuration. Make sure you're comfortable with your periodic table and how to use it. And make sure you know your isotopes, know what they are, know how they react.